Welcome to this video. Welcome back if you came from part 1 of me starting to solve this practice exam of AP Precalculus. This is released by the College Board, actually, this practice exam. Okay, so we left off on number 9, so let's continue. This is the no calculated portion, by the way. Okay, the graph of y is f of x consisting of 4 line segments and a semicircle is shown here. X is between -3 and 3, inclusive. Which of the following is the transformed graph of f of x plus 1 minus 2? Okay, so hopefully you remember your transformations. When we have this minus 2, this means it shifted down by 2. And we have this x plus 1 over here. It's shifted to the left by 1. Okay, so let's see where it's shifted down by 2 and to the left by 1. Okay, so we can even take like this point, for example. If we shift it down by 2 and then to the left by 1, it should be at -2, comma, -2. Okay, so it kind of looks like this one actually. So is it just A? It looks like it is. Okay. Notice how the other ones don't have that point over here. Okay? This is how we transform functions. This is a quite easy case, actually. Just a vertical shift and a horizontal shift. And just remember the direction because, well, the vertical is easy. When it's negative, that means you shift down. When it's positive, you shift up. For the horizontal one, if it's minus, it shifts to the right. If it's plus, it shifts to the left. Exponential function f is given by f of x is a b to the x, where a and b are positive constants. Table gives values of f of x, selected values of x, which the following statements is true. So it looks like from the choices, we have to know if it's exponential growth or decay. Well, the terms are increasing, and you can see it's being multiplied by 2, actually. So it's going to be an exponential growth because it's growing. It's not decaying. It's not getting smaller. So eliminate A and B right away. Okay, so now is it C or is it D? Okay, so as I said already, it should be growing. It's being multiplied by 2 every time, every unit of 1. As x increases by 1, you multiply f or the y value by 2. So we know that B has to be 2. So B would be, that is only satisfied by D, actually. Okay. Function f is given by f of x is x squared plus 1, and the function g is given by g of x is x minus 3 over x, which the following is an expression of f of g of x. So this is just testing if you can find the composite function. So for f of g of x, wherever there's an x, for f of x, wherever there's an x, you plug in g. So f of g of x would be x minus 3 over x, that's g. We're going to plug that in as x. So this whole thing is squared plus 1. So now we just got to simplify. So how can we do that? Well, the top, when we have this, remember properties of exponents, you can do this. X minus 3 squared over x squared plus 1. Okay, so how do we simplify this? We can expand the top. We can FOIL it out. So it'll be x squared minus 6x plus 9 over x squared. Okay? And then for 1, we probably want to, actually, let's just keep it like that because it looks like it's choice C. Okay? If it didn't have this, maybe you have to, for example, change this one to x squared over x squared and then combine. So they could have totally did that also and given that simplified result as a choice. But it looks like since we were solving it, I saw that I already had a matching answer. So that's it. Okay. Table shows values for a function g as selected values of x, which the following claim and explanation statements best fits these data. Okay, so just eyeballing the choices is they're asking if it's multiplied linear or quadratic, okay? So let's try to find that first before reading all this, okay? So this is probably just explaining why linear or quadratic. So when it's linear, the step between each value of x should be about the same. But if it's a linear function, it will be the same. When we're trying to model it, it should be very close because it might, so let me even draw it out. So if for a linear function, it'll look like that. But if it's close enough, because you have sample points where it's maybe like this, if it's close enough to linear, then the linear is a good model. Obviously for here, a quadratic would not be a good model, even though like the points are not exactly on the line. Clearly the linear model is better than like a quadratic, so let me even draw it, something like that, okay? So let's see how the change is. So to go from here to here, how much do we need to add? It looks like it is 25. Okay, now to go from here to here, what would that be? That is plus 19, it looks like. Okay, now to go from here to here, it looks like it is plus 13. Okay, and then to go from here to here, it's plus 7. So clearly it's not linear because it's actually getting smaller. So let's cross out A and B. Okay, so it has to be quadratic. Now, which one is it, C or D? So let's see. Because the rate of change over consecutive equal length input value intervals is constant. So this description, this reason only is applicable, it's only true for linear models. It's not true for quadratic. So let's see what D says. Because the change in the average rates of change over consecutive equal length input value intervals is constant. It should be this. It sounds familiar to me also. Okay, so if we look at the difference here to here, from this plus 25 to plus 19, how do we get there? It is minus 6. To get from 19 to 13 is minus 6. To get from 13 to 6 is minus 6. So that's what it's saying. When we take the second differences, it's the same, so it's quadratic. All right? The function g is given by g of x is 7 sine 2x, which the following is an equivalent form for g of x. Okay, so you would need to know an identity, so I'm not even sure if they give this to you in a formula sheet or something. I didn't see it, so I'm assuming you need to know this then. So just apologize that I don't know what you actually need to know on this AP Precalculus exam. I'm just solving these problems to hopefully help you out if you're studying. But anyway, so I know how to solve this though. You need to know the identity that sine 2x is 2 sine x cosine x. So let's write g as 7 times 2 sine x cosine x. So that's 14 sine x cosine x, and that's A. Okay, so I'm assuming you need to know this identity, which is not too hard to memorize. Function g has the property that for each time the input value doubles, the output value increases by 1, which the following could be the graph of y is g of x in the xy plane. Okay, so it says that every time the input value doubles, the output value only increases by 1. So for example, if you start from 1, so when you double it, that's 2, increases by 1. When you double 2, that's 4, that increases by 1. When you double 4, that's 8, that increases by 1. So it happens that I was showing the example on choice B, and that works. And it actually sounds like this function to me. I already know that it's not linear because whenever it doubles, whenever the input value doubles, the output value should double also. That's how linear works, is 1-to-1 type of thing. So it's not D, and it's not C. Okay? But I take that back, actually. If the input value doubles, the output value increases. But yeah, actually, it does double. For example, here, let's take this example here. 2, if it doubles, it should be 4, right? So then, actually, I'll put that increase by 1. So if it doubles, then, does it increase by 1? It doubles, increase by 1? No, it doesn't work like that, right? So it doesn't work for linear. And then I already know that for this looks like an exponential, it for sure won't work, because when you double, it's going to increase a lot more when you exponentiate. So yeah, so you can do it to slow it like I did for each the graphs, or you can just by intuition tell that it's not linear, and for sure it's not exponential, or not even quadratic. So it has to be this one. It's actually slowing down, it sounds like. So this one's the slowing down one. Okay. Complex number is represented by points in the complex plane. Complex number has the rectangular coordinates 3, 3, which the following is one way to express the complex number using its polar coordinates r and theta. Okay, so this is just testing if you remember how to convert between rectangular and polar coordinates. Okay. So in rectangular coordinates, it will just be 3 plus 3i, as simple as that. So you can go through all the choices and figure out which one's 3 plus 3i. Otherwise, you also should remember how to get the x components and the y components in terms of r and theta. It would be r cosine theta plus r sine theta times this guy times I. Okay, so what is r? R would be your, r squared would be your x squared plus y squared, and your theta would be your inverse tangent of y over x. So let's find theta first. Okay, that one looks quite easy. It'll be 3 over 3. Okay, so that's inverse tangent of 1. That is pi over 4. Okay, this, remember, when you take the inverse tangent, the domain of the inverse tangent is quadrants 1 and 4. So we have to check if it's quadrant 3 or 1, because this is positive, okay? And since this point is in quadrant 1, we can just take pi over 4. If it was like -3, -3, then we know it's in quadrant 3, so it would be pi over 4 plus another pi, so 5 pi over 4, something like that, okay? But since this is in the quadrant 1, we could just take this directly, because we know that the domain of arctan is in quadrant 1 and 4. Okay, so we can eliminate some of the choices already, right? So it doesn't look like it's C or D. Okay, so now let's find R. So R squared is just 3 squared plus 3 squared, which is 9 plus 9, which is 18. Okay, so R would be square root of 18, which is square root of 9 times 2 on the inside of the square root, which is 3 root 2. Okay, so it looks like it's choice A then, because remember I just said it's R cosine theta plus R sine theta times I. So we found R to be 3 root 2, and cosine of our theta, which we found was pi over 4, sine of our theta, which is pi over 4. So choice A. Okay, and actually I'll call that part here. It's almost 15 minutes. Okay, hopefully this was helpful. Please like this video if you found it helpful, and please subscribe also to the channel if you haven't already. And when you do subscribe, you'll also get notified for when I post the next video of the next few problems that I'll solve. So hopefully I see you in that video also. Bye.